All right. Well, happy Friday, everybody. And I hope you guys are doing well. Maybe I'll just take a moment and check in with you guys and just see how your first couple weeks are going. So far, so good, sort of okay. I don't know. How's the homework coming along? It's going okay, not too bad. All right, pretty good. Okay, all right, well, and all right, okay. So nobody's doing fantastic and great and wonderful, but that's okay. I guess all right and pretty good and not too bad is what we can hope for these days. So well, I do hope things are going all right, and we'll see. And okay, well, let's take a look at today's lecture. Today we'll be talking about flow control, and we'll also introduce lists and some of the properties of lists in Python. Okay, so pretty much as you do programming and you write functions and whatnot, and you want things to happen a certain way, you need to have conditional statements. And so we have the if, the else if, the elif, and the else. Okay. Again, in Python, we don't need to use parentheses. We don't have curly braces. What we use is a colon, and we use indentation. So we use a colon to end the conditional statement. The lines after the colon are indented, and everything that's indented is associated with that if statement. When there's no longer indentation, then the lines are no longer associated with that if statement. Okay, if you have else or else if, they have to be at the same level of indentation as the first if statement. Okay, so here's just a very basic example. All right, here I'm going to just set x equal to -3, and we're going to say if x is equal to 0, then print x is 0. And we've got else if x is greater than 0, print x is positive, and else colon print x must be negative. And so all of these statements, the indented lines are associated with the previous conditional statement, or the conditional statement above it. And yeah, no curly braces. We just use colons and indentation. All right, and so with the -3, it fails this, so it checks the next statement and it fails that, and so it prints -3 must be negative. Okay, again, just like pretty much any other language, the else if, or the else, only gets executed if the associated if statement is false. So here I've got x is equal to 100, and my first condition that I'm checking is going to be if x is greater than 0, print x is positive. And so in this case, when x is 100, this is true, and so it's going to print 100 is positive. And because this is true, it's going to skip everything else. It's not going to evaluate this else if. Okay, this else if is or elif, it does not get kind of triggered here, because this statement ends up being true. This is only going to be here if it's only going to get evaluated if it is negative. Can we have a parentheses around the condition? Yes, you are allowed. So parentheses are not required, but you are allowed to use them, especially if you have kind of like a complicated statement and you want to kind of group things together. You are allowed to put parentheses around the statements there. Okay. All right, and so in this case, this line, x is greater than 3, even though it's true for 100, this will never get executed, because as soon as it's greater than 0, it's going to activate here. All right, you can nest conditionals inside each other. But if you do that, it could get hard to read. All right, so here I've got x is equal to 5 if 0 is less than x, or if x is greater than 0, then we can check a second condition. And if that's the case, then we can check if x is less than 10. All right, and this will just print x is a positive single digit number. So first this has to be true, and then this has to be true, and then if that's the case, then the statement will be true. All right. It's probably better to use and, okay? And in Python, we use the statement and. The kind of the ampersand symbol and the vertical line, those activate, can be used in places like NumPy when you need to do kind of element-wise Boolean checks, but generally for if statements, or not generally, but yeah, whenever you're writing an if statement, you'll be using the and, okay? And so here we can do if 0 is less than x and x is less than 10, we can just kind of put that, and we can put the condition on one line here. Okay. Python is also pretty smart, and you can just do something like this as well, and this will also execute as well. Okay, we talked about defining a function, and there's kind of a certain class of functions that are handy, or not handy, but that make use of kind of this known programming technique known as recursion. Okay, and so when you do recursion, what it does is the function within the code for the function is that the function calls itself. Okay, the function calls itself inside the function. So when you write a recursive function, in order to kind of prevent it from going on forever, you need to write a base case, okay? A base case that will not call the function recursively, and that allows the function to end. So here is a very simple recursive function, and this is going to be called countdown, and you give it some number n, and basically without the base case, all right, without the base case, what we're going to do is we're going to print n, and then we call the function on itself. Okay, so we call countdown, but this time with the number n minus 1. Okay, and so if we started at 10, okay, it would print 10, right? It would, so ignore the base case for the moment. Okay, we would call countdown. So the function and countdown prints out n, and then it would call countdown on 9, and then so that 9 would print out 9, and then it would call countdown on 8, and countdown on 8 would print out 8, and then print out 7, or call countdown on 7, and this would repeat until forever. Okay, and so to prevent it from running forever, we have a base case, and we're going to say if n is less than or equal to 0, under this condition, if this base case is true, all right, if n is less than or equal to 0, we're going to print blast off. We don't make a call recursively to itself, and this will stop the function. So so if I call countdown on 3, again, it runs, it prints out 3, calls countdown on itself with 2, and when it does that, it prints out 2, and then it calls countdown on itself at 1. Okay, and it prints out 1, and it calls countdown on 0, and in the case where countdown is called on 0, it prints blast off. Okay, and so there we go. And that would be a recursive function. So, you know, you could do apply a recursive function for you know, a variety of kind of situations, especially where the situation kind of basically is, you know, repeat the process until until you get an answer. So, you know, a common case would be something like a prime factorization. Basically, you know, you apply, you try to extract a prime number, you'll get a remainder, and then you kind of keep calling it on the remainder until the remainder itself is a prime number. So, so the execution of this recursive function, countdown 3, 2, 1, here, it says, you know, the execution begins with 3, and since n is greater than 0, it prints out the value of 3, calls itself with 2, does that, calls itself with 1, calls itself with 0, and then at this point, it prints the word blast off and returns, and then, and technically, all of the other functions that previously got called, countdown for n equal to 1 returns, countdown that got n equal 2 returns, and the countdown that got n equal to 3 returns. So at the end of this, after this finishes executing, it, you know, kind of returns, and in all of these cases, it's basically the final cases, it returns none. And so in all of these things, they all return none. So the output of that is just to return none. Okay, so here's another function, and this will just kind of print a string n times. And so here I'm going to just say print n. It takes in 2 arguments. One will be a string, the other will be n, the number of times to repeat it. Now this is a very silly function because you can just take a string, you know, and we can just write some kind of loop or something to have it do this. But again, recursively, we have a base case. All right, we have a base case for when n is less than or equal to 0, and that will exit the function, and we exit the function by just doing return none. Okay. Otherwise, what we do is we'll print the value, and then we call the function itself using the same string and, you know, a different number, n minus 1 rather than n. And so it will start off with n equal to 3. It prints out hello. It calls itself with n equal to 2. Prints out hello. Calls itself with n equal to 1. It prints out hello. And then it calls itself with n equal to 0. And when n equals 0, it returns none. And technically, all of the other functions that have been called recursively also return none. So the final function returns none. Factorial would work well for recursion, because effectively 4 factorial is 4 times 3 factorial. 3 factorial is 3 times 2 factorial, and so on and so forth until we reach 0 factorial, and 0 factorial is 1. Is return none similar to break? Is there a break? There is a break keyword in Python. There is a break keyword in Python. Yes, and then could this also be done with while loops? Yes, absolutely. Okay, so all of these things, you know, I'm doing recursive examples here, but yeah, absolutely. We can do for loops, while loops. There's all sorts of other ways to approach it. Okay, recursive functions, recursion is a bit of a strange concept, and it can make people feel a little bit uncomfortable, because certainly I think a for loop and a while loop, these are maybe feel a little bit more intuitive than kind of calling a miniature version of itself or something when we do recursion. But technically, for a language to be Turing complete, okay, so theoretically, if we're getting into computer science stuff, you don't actually need to have for loops or while loops. Everything can be achieved through recursion. Now, for loops and while loops and all of those other loop structures that we have are kind of a convenience, and people like them, and so a lot of languages include them. But you can, with a little bit of thought, you can achieve everything you need using just recursion. Technically, it certainly will make your life harder to use recursion only, but it's kind of like challenge mode, right? If you wanted to say, you know, I'm not going to allow myself to use any kind of loop structures, but technically with just recursion, you can achieve everything. So anyway, here here's a factorial function. If it's 0, return 1. Otherwise, return the product between n and we're going to call factorial on n minus 1. Okay, so we're going to call factorial on n minus 1. And so this is interesting. This is not, in all of these other examples, we've just kind of been printing the value, but here the value we're going to return is going to be n times the value that the next thing returns. Okay, so we've got return 1, and so that's the base case. And so all of these things will, this nested structure will end up working. So anyway, 4 factorial is indeed 24, and 5 factorial is indeed 120. So it is working, but yeah, first when we call it with 4, it's going to return 4 times factorial called on 3, and that will return 3 times factorial called on 2, which will be 2 times 1 factorial and 1 times 0 factorial, and at 0 factorial we reach 1. And so that returns 1, and then we'll get back 1 times 1, and then we'll get 2 times 1 and 3 times 2 times 1, and then 4 times 3 times 2 times 1. So it does work. But yeah, it's it gets big. Okay. Oh, so this is the what I was just saying. So it's technically possible to accomplish all forms of repetition with recursion only, but yeah, we can do repetition using other things like loops. Okay, and so our basic loop structure is the for loop, which what this does is it just takes the chunk of code that you have, and it just repeats that chunk of code for each value in some iterable. Okay, and we've got several iterable structures in Python. We have the lists, the tuples, the range, even strings are iterables in Python, and we'll cover all of these kind of the details of each of these things a little bit later, and we'll look at lists later today. But we've seen tuples not as an iterable structure, but just as kind of this concept that as a function can return a tuple, which will consist of multiple values grouped together. Okay, so here I've got a list with the numbers 5, 7, 2, and 1, and I initialize some value y with 0. And I'm going to just say for each value, for x in values, okay, for x in this iterable list, what we want to do is we want to print out that number, and then we're going to increment y by x. Okay, so I've got y plus equals x, and that's shorthand for y is equal to y plus x. Okay, so Python has this, whereas if you're coming from R and if you've never seen this before, you would have to do something like y equals y plus x. But plus equals is a fairly common convention that appears in lots of languages, and it also appears in Python. And so anyway, after we increment y by x, we'll print out the statement running sum is y. And so this will iterate over all of the values inside the list. So it starts off with 5, it adds 5 to 0, running sum is 5. Then the next value is 7, the running sum is 12. The next value is 2, the running sum is 14. The last value is 1, the running sum is 15, and it ends. Okay. And that's it. Okay. And if we wanted to, we could have done this recursively. We could name a function, and basically we would call the function on the full list, and then we would call it recursively on basically the list minus the first element on the remaining list. And then the base case would be when the list either has 1 element or when the list is has 0 elements in it, then that's when you kind of stop. But again, for loops just make our life easier without having us to think about this recursive structure. So here is a string. Okay, this string is UCLA space UCLA, and the string itself is iterable. Okay, and so we can say for a or for something character in UCLA or in the string, and basically each iteration will be one of the characters in the string. Okay, and so what we're going to do is we're going to say take that character, make it uppercase, add on an exclamation point. So, you know, we get some kind of modified 8 clap, I guess. We've got U exclamation point, C exclamation point, L exclamation point, A exclamation point, and then I don't know what this is. This is nothing exclamation point, but anyway, you can do that, and you get the result of iterating through a string. Okay, I've forgotten to do this. Let me give you your first view quiz answer for today. First view quiz answer today is A as an apple. A as an apple is your first view quiz answer. The range object. The range object is a sequence of numbers, okay? You use this to kind of establish the sequence of numbers, and you have to kind of keep in mind, Python is 0 index. The quiz is locked. Did I forget to, did I mess up the quiz time again? I always do this. Oh yeah. Available from, okay. Sorry, let me fix this. Okay, that should be fixed now. So the quiz should be available. Okay, so first view quiz answer is A. And okay, so we've got the range object. And so Python is 0 indexed, okay? And so when you call range 10, it's going to create basically a range of values starting at 0 with a length of 10. So it's pretty much like 0:9 in R. Okay, it's going to be the integers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that will be it. Okay, now shorthand, range 10 will just kind of the default value is start value is 0, the step size is 1, and 10 will be kind of your output length. But here you can kind of specify things. You can specify the start, end, and the step size by itself. Okay, so and by default, the range will begin at the start value, increment by the step size, and go up to but not include the end value. If you only specify one integer value, then it's going to assume it starts at 0 and the step size is 1. So if you do range 10, it's going to start at 0, end at 10, which means it starts at 0 and goes up to but does not include 10, so 0 through 9. And if we were to kind of print this out for I in range 10, and we say print I, and this time I just say end is equal to a space rather than a new line, it will print out the integers 0 through 9. Okay. Now, when you call a range object, it kind of keeps it as this, or as the range function keeps it as kind of a range object structure. Okay. And it and only when you kind of iterate through it does Python kind of go through and figure out what these values are. Only when you kind of start working with it. So here, range 5, 10 would go 5, 6, 7, 8, 9. It starts at 5, goes up to, but does not include 10. You can throw the range object inside a list, and then Python will go through and kind of realize each of these values. All right, so the evaluation of the range object, it starts off with instructions as just kind of like saying start 5, go up to, but don't include 10. But it doesn't, Python's not actually going to calculate all of these numbers until you ask it to, by throwing it inside a list or throwing it inside a loop structure or something like that. Okay, here we've got range 0, 22, and this will start at 0, increment by 2, and go up to, but does not include the final value. So it goes up to 18. If you say go from 0 to 21, then it keeps going until it reaches 20, and then it stops. So even though 21 is not a multiple of 2, this will, it reaches this point, and it goes again. goes up to, but it won't include the final number there. If you try to give it something like 20.1, something that's not an integer, Python throws an error. Okay, it says you can't do this inside a range. Okay. All right. You can also specify negative values for your step size, and so this will count backwards in the range. So you get 109876. If you don't specify a negative step size, the default step size being 1, if you try to do this, it will return basically no values. Okay, and here you get an empty list because it says, you know, there's nothing to give here. Okay, so those are range objects, and they're very, I would say they're very frequently used in for loops. So you'd often do like for I in range 100 or something like that, and that's kind of your structure that you have. Okay, or you could even do for I in range n, where n is some variable. Okay. We have the while loop. The while loop will run until the conditional statement is false. So we have I equal to 0, and we're going to say, well, I is less than 10, print I, and then increment I by 1. So we're going to start at 0, and then we go until I equals 9. And then at the next iteration, I becomes, so after we print 9, okay, we print 9 in the space, I becomes 10, and the while loop runs again, but this time I is equal to 10, this statement becomes false. I is no longer less than 10, and so it's going to quit. So if we ask what is the value of I, at this point, I has the value of 10. So I think someone had asked a question about break and continue, and so return none is just kind of the end of a function that will kind of end the function, return no value. When you're working explicitly inside a loop, okay, whether it's a for loop or while loop or whatever it might be, you have break. Break will just quit the loop, and then continue will skip the remaining lines of code that exist in the loop and go to the next iteration of the loop. In R, there's a similar keyword, but it's we have break and next, but continue and next are pretty much the same ideas. Okay, so here I'm going to say for n in range 20 and for n in range 20, so we start off at 0, right? And what we're going to do is we're going to say divide, do modular division. So we're going to say if n is divisible by 2, that is, if n divided by 2, if the remainder is equal to 0, so meaning if n is an even number, continue. And continue just says skip the rest of the lines of code, go to the next iteration. So if we start off at 0, this is going to be true. So we're going to hit continue. And then at the next iteration, n is 1. This is false, so we don't run continue, but we'll run this line, right? We run print 1. And then at the next iteration, it goes to 2. This is true, so we continue immediately to the next iteration. This line of code is not triggered. And then it becomes 3. This is false, so this is not triggered, but this is. This gets executed, so we get 3. And so on and so forth, and we end up printing out all of the odd numbers. Okay, an example to create Fibonacci numbers. Okay, so here here's another example. So here we printed out all of the odd numbers. Here I'm going to run some example to create Fibonacci numbers, in that we will start off with the values 0 and 1. Okay, we're going to set these to A and B as using tuple unpacking. So A and B are going to be set to 0 and 1. And then we're going to say the max value that we want to work with is going to be 100. So give me all of the Fibonacci numbers until I go up to less than 100. I start off with an empty list. Okay. And so while true means it's going to run forever. It's going to run forever until it hits a break statement. So if you got while true, this is just run forever until you reach a break statement. So what we're going to do is we're going to take our values A and B, and we will say B gets assigned to A, and then the next value will become A plus B. So we start off at 0, 1. We're going to set 1 to A, and then the next value will be A plus B, okay, which in our case will be 1. And we're going to just say if A becomes greater than 100, then stop the loop, okay? If A goes greater than the maximum value, break out of the loop, okay? Otherwise, or not even otherwise, okay? And then if that doesn't get executed, then what we do is we append the value A to the list, okay? So we're just going to tack on whatever A is to the list. And so when we do this, we get the values 1, 1, 2, 3, 5, 8, 13, so on and so forth. We get the Fibonacci sequence, okay? And we're taking advantage. So I think this is kind of a fun way to do this. There's lots of ways to get your Fibonacci numbers. I think this is kind of a fun way using Python's tuple unpacking, okay? And we're going to basically just kind of shuffle down the numbers, right? B becomes A, and then the next value, the new B, becomes A plus B. So we get that. Okay, let me go ahead and give you your second view quiz answer for today. Today's second view quiz answer is the letter C, C as in cat. C as in cat is your second view quiz answer. Okay, all of these conditional statements that we've mentioned today, they rely on Boolean expressions, right? We need a true value or a false value in order for us to either trigger an if or not else if or anything like that, right? So, your basics, you've got your test for equality at 5 = 5, 5 = 6 will be false. Whereas you can say 5 not equal to 6, that's going to be true. Okay, so this is your basic tests for comparison. You got 5 greater than 6, 5 less than 6, greater than or equal to, less than or equal to. All right, so no surprises here. Okay. Some of these things, okay, we can say, is character 5 equal, is that the same thing as integer 5? Okay, so when we do this, these two things are not the same. Okay, we can compare strings, and it goes in alphabetical order, right? And when we compare strings, this is going to be with the strings coming earlier in the alphabet being less than things later in the alphabet. And the order in Python is all uppercase letters come before all lowercase letters, okay? So capital A is less than capital B. That's not a surprise. Capital A is less than lowercase a. And capital Z is less than lowercase a. This might be the surprising one, okay? And this is just how Python internally has sorted the alphabet, okay? So A becomes before B, comes before C, but all of the capital letters come before all of the lowercase letters, okay? The ordering is different in other languages, so just be aware. Okay, as far as logical operators, we have and, or, and not. And so, when you combine these values, you have, true and true, true and false, true or false is going to evaluate to true. And then you also have not true. And these operators, these logical operators, are written in lowercase, And when you write them in Jupyter, Jupyter will the kind of the highlighting syntax will highlight these in colors to indicate that these are special words indeed. Okay. So a couple of things, right? So we have false or not false. So the not false will evaluate to true. So now we have a false or true, and that becomes true. True and not false. So the not false evaluates to true. So that also becomes true. Okay. We can see if something is divisible by y, right? So we can say n is equal to 6. Is n divisible by 2? It is. And is n divisible by 3? It is. So 6 is true. Whereas if we tested it for 8, that's going to evaluate to false. And you can do these kinds of logical operations and stuff, right? So here, instead of and, I put in or. Is 8 divisible by 2 or 3? It is. Okay, so when it comes to writing a function, all right, I advise going straight into writing the function. You should always try to kind of write your code in the global environment first and see if you can achieve the task. And then once you do this, then you can consider encapsulating the lines within function, right? So this is just some pseudocode. So imagine you're giving instructions to like a little person or something, and you want to say, draw a square. So you can do something like go forward, 100 pixels, turn left 90 degrees, go forward 100 pixels, turn left 90 degrees, go forward 100 pixels, turn left 90 degrees, go forward 100 pixels, and turn left 90 degrees. Okay, so this would be giving instructions to a person to kind of walk around and draw a square. Okay, so this would just be executed, say, in the global environment. And we want to see if this, can we encapsulate this into a function. So basically, a function just kind of takes several lines of code, associates a name with the statements, and allows us to reuse the code. And so we can say, you know what, if we wanted to create a function called draw a square, we can just take those instructions, go forward 100 and turn left 90. We could put that inside a for loop. So we can say for I in range 4, meaning we're going to have this go forward, run this 4 times. It's going to go up for I 0, 1, 2, and 3. So I takes on the value 0, 1, 2, 3, but effectively 4 times. There's no reference to I in here, so it doesn't even matter. It just says do this 4 times. And this would end up doing exactly what we want. We could draw a square. And then once we achieve the thing that we want to do, we can generalize it, right? So we can do, instead of specifying it's always going to be a square with a side of 100 pixels, we can take that value 100, turn it into a variable, right? A variable like length, and throw that into as one of the argument names for the function, okay? So we can say draw a square where you can give it a variable of length and then execute that code. And so this will just be the same function, just ever so slightly altered. Okay, and then if we wanted to generalize that even further, say draw a polygon, okay? So rather than, so kind of the rules for a polygon is you take the angle size is basically how 360 divided by how many angles you have, right? Because if it's going to kind of complete itself, that's what it's going to be. So if you wanted a regular pentagon, okay, equilateral pentagon, then the angle that you're going to do is going to be 360 divided by 5, right? And so here, again, just not a function yet, but we can say for I in range 5, go forward 100, but your angle that you're going to turn is only going to be will be 360 divided by 5, which is, I don't know, what is that? 72 degrees, okay? And again, with a hexagon, this time, the angle that we're going to go is going to be 60 degrees. You turn left 60 degrees, you turn left 60 degrees, you turn left 60 degrees. And that will be how big of a, how much you would turn to make the hexagon, right? The internal angle is 180 minus 60. Okay, the internal angle of a hexagon is 120 degrees, but then how far did it go from going forward? You turn left 60 degrees. Okay, and so I think we can kind of see the where the variables can go. So if we want to generalize this for a polygon, okay, we can generalize for some n-sided polygon, and I'm sorry, there's some variable t here. I don't know what t here is doing. Okay, that's unnecessary. But the angle that we're going to turn will be 360 degrees divided by n. Okay, and then we iterate for I in range n. We go forward the length, and we'll turn left at our angle. And I'm sorry, I don't know why that's a typo there. Okay, so that's just some very basic tips for creating a simple function in say Python to generalize. Okay, let me I want to introduce some basic things that we can do with lists in Python. Okay, we create lists using square brackets, and as far as lists go, they can contain a mix of data types. And you can also nest lists inside other lists. So here I've got a list called fam for family. We've got the names of people, Liz, Emma, mom, and dad. So we've got string types. And then we also have, this is their height in meters, 1.73 meters. Emma is 1.68. Mom is 1.71. Dad is 1.89 meters tall. And these are the heights that we have, okay? I could, if I didn't want them all at the same level, we could have a nested list structure. And so here, fam2 is a list of length 4, and each of those elements is a list of length 2. So here you can see the square brackets. We've got Liz, comma 173 as a list inside fam2. Emma, comma 1.68 is another list. So you can have this, either of these, you have these different nested structures, and Python will print these out like this if we ask for what does fam look like, or fam2. Okay, so these are different structures. Fam is a list of length 8. Fam2 is a list of length 4. So if you wanted to subset a list, just keep in mind the lists, again, Python is 0 indexed, all right? And you can use single square brackets with an integer to subset the list. So we can say, what is the zero index element of fam, right? So fam is this structure. What is the 0 index element? It's just the first element in the list, and that's going to be the string Liz. Okay. Whereas what's the 0th element, 0 index element of fam2? That structure, the first element there is this list of length 2 in the second list structure. When you use negative numbers, they count from the end. To get this, we have I can do fam single square bracket 0, which gives me this list, and I can do single square bracket 0, which gives me the 0 index element in this list, which will just be the character string Liz. When you do -1, it counts from the end. Okay, so if you look at the original list, -1 will give you the last element. Okay, this is -1, this is -2, -3, so on and so forth up to -8. Okay, -1 here is just this element. -1 here gives me the list. And again, just like kind of you can run the square brackets again, I've got -1, and that will give me the last element in this list, which will be 1.89 here. All right. Is that okay? The negative indexes on lists, which is different from, say, subsetting in R, okay? You can slice, all right? Slicing will not include the item in the index after the colon. So for example, you can think of slices happening at the corresponding commas, okay? So if this is my list, okay, Liz, comma 1.73, comma Emma, comma 1.68, and I say slice from 1:3, you can think of this happening as slicing from the first comma to the third comma, okay? So the first comma is here. So you can think of a 0 comma being here, okay? And I guess the 8th comma would be over here, but this is the first, second, and third comma. So we are slicing from the first comma to the third comma. And so when you slice from 1:3, you're gonna get 1.73 in Emma. Okay. If I do slice from 1:2, you can imagine slicing from the first comma to the second comma, and we get the value 1.73. We get a list back with that. If you just do, if there's no colon, then it will just give you the one index value, which will be 1.73. But if you do 1:1, so if you slice from the first comma to the first comma, there's no value to return. Okay, so you can think of slicing happening at the commas. And so whenever you use a colon, you are slicing, and you're basically saying go from this comma to this comma. If you slice from the 0, okay, 0:2, we're starting, you can think of a 0 comma being here, and the second comma is there. So 0:2 will give us Liz, comma 1.73, okay? And you can imagine an 8th comma at the very end of the list. And so from the 6th to the 8th will give us the last two elements. Okay. If you do, if you leave off something after the colon, so here I do 2 colon, okay, this will give you basically from the second comma all the way to the end. And similarly, you can do nothing, :4, and this will start at the very beginning from the 0th comma up to the 4th. And that's list slicing, and that's going to be a very important way to kind of subset your lists to use very frequently. Okay, if you put in no elements before and after the colon, this will just give you a copy of the list. Okay, this will give you a copy, technically a shallow copy. And then if you try to subset with nothing inside, you get an error. Okay, so so you can't do this. So here's just a few more examples. You can slice from, say, kind of backwards, or not backwards. You can say slice from the -5th comma to the -2. So you can think of counting backwards. All right, 1, 2, 3, 4, 5. So going backwards, this would be the 0, -0, -1, -2, -3, -4, -5. So from the -5th comma, -5 to the -2, which is right there, we get that. Okay. Fam2, we can go from the first to the third colon or third comma, and we get this part, and this part got cut off. Okay. But we can say, okay, I want the 0 element, and then now I want from the 0 to the first, and this would just return Emma here. I'm sorry, it just got cut off there. Okay, lists are mutable. Oh, I'm going over time. Okay, so one thing is that I guess I'll have to cover this a tiny bit later, but let me give you your last view quiz answer. Last view quiz answer today is D as in dog. D as in dog is our last V equals answer. But one thing that you have to remember is that lists are mutable. And so if you take the list and assign it to another name, both of those names refer to the exact same object. Okay, so here I've got fam as a list. I create a second list called second. It's second is equal to fam. Both of these things point to the same object. So here I'm changing the 0th element to sister. Instead of Liz, I'm changing it to sister. And when I say print out second, indeed that first element, the 0 index element has changed to the sister. But also fam itself, it's pointing to the same object. And so this, when you reflect it, it reflects that the 0 index element in fam has also changed. Okay, and this is gets at the idea that lists are mutable. That lists, the objects themselves actually change. Okay, but I'm out of time, so we'll end here today. Have a good weekend, and it's a holiday weekend. Dr. Martin Luther King holiday is on Monday, so I will see you guys on Wednesday. So have a great weekend. We'll see you guys later.